In this module, we are going to be covering the topic of bond pricing. So we are going to see when a company issues a bond, how is the price determined? We'll talk about the difference between the face value of the bond and the actual price, which in many cases they are not one and the same. So we're going to see that this all boils down to calculating the present value of the expected cash flows of the bond. So as I mentioned, bonds often issue for a price other than their face value. As one example, you could have a $100,000 bond that issues for a price of $105,000. What this basically means is that some bondholder is going to pay a $105,000 amount to purchase this $100,000 bond. This gives us a $5,000 premium. Now, we do discuss the topic of premiums and discounts in a separate module, but just to give you a brief overview, the reason a bondholder would pay more than the face value of the bond is generally that the interest payment being made by this company is higher than the interest payment that is being made by other average companies on the market for the same risk category. So that's generally why there would be a premium. Now, the other thing that's important to note is that even though the bondholder is paying $105,000 right now, let's say this was a 10-year bond, what they would actually be getting back at the end of the 10th year is just the $100,000 face value. That's all they would receive back. Now, the bond price is generally going to be issued as it's going to be stated as a percentage of the par value. Par value is the face value. So in the example above, that bond would issue at 105, which would basically be 105% of the $100,000 face value. So the question for us today is, how exactly is this price determined? So first of all, the fair value of the bond, in other words, the price that it will generally issue at, is equal to the present value of the future streams of cash flow that is expected to generate. So what we mean by this is that when an investor buys this $100,000 bond, they are expecting to get two things back in the future. The first thing is that they're going to be getting interest every period. It could be every year, it could be every 6 months, whatever the period of the bond is. And that's an important thing to note, though. For our example in this module, we're going to be talking about annual bonds, but many of them are semi-annual, in other words, twice a year. You could have quarterly bonds, so you have to pay close attention to what period it actually is. But the first cash flow, they're going to get interest every period. Now, the interest they're actually receiving is going to be the same amount every year in our example. This is considered an annuity because it's the exact same amount over equal periods of time. Now, that term annuity will come up again a little bit later, but I just wanted to point that out. You also have the face value of the bond that's going to be due at maturity. So at the end of this 10-year life, the bondholder is also going to get whatever that face value was, $100,000 in our example. This is considered a lump sum in a future amount. So here we bring up the topic of present value. Now, again, I discussed the time value of money in much more detail in another module. We talk about both present value and future value. For the purposes of this module, I'm going to narrow it down to just the topics related to bond pricing, which would be the present value of a lump sum and the present value of an ordinary annuity. So we said that we have two future cash flows, the lump sum and the annuity related to the interest payments. So the lump sum in this case is $100,000. We're going to get $100,000 in 10 years. Now, the thought here is that we want to find out, what is this really worth today? Today we need to price this bond. So what is that future cash flow really worth today? If we had the choice between $100,000 today and $100,000 in 10 years, nobody would ever choose the 10-year amount. So because of that, when we're looking at the present value has to be less than the future value. Otherwise, nobody would choose it. So what we're basically saying there, we'll see these calculations a little later, but if we were to use a 10% market rate for our calculations, today's value for that $100,000 future payment, it would only be worth $38,554 today. So what this basically means is that if we invested $38,554 today at 10% and we left it there for 10 years, we would have that same $100,000. So one way to think about present value is that we are just backing out the future interest. We're trying to figure out what do we need today to invest at that interest rate and get a certain amount in the future. So in this example, the $100,000 is a known future value. What we don't know up front is the present value, and that's what we need to calculate. We need to figure out how much is it worth today. So in this case, it's $38,554. Just as a quick check, a logic check here, your present value always has to be less than your future value. In other words, the known amount. So if we want to find the present value of $100,000, it's always got to be less than that $100,000. Now, how much less will depend on exactly how long the period is and what interest rate are we talking about here. So keep those things in mind. Now, there are a few different ways to calculate this. I'm going to walk you through some of the basics here, but it all boils down for the most part to using a table or Excel. This is the actual formula if you want to calculate this rather than using a table, rather than using Excel. The present value factor. So in other words, this factor is going to be what we multiply every dollar by to figure out what percentage, so to speak, is present value. So to calculate this, we take 1 and we divide it by 1 plus the interest rate, and we take that 1 point whatever to the nth power, n being the number of periods. So the good news is you don't have to go through that calculation all the time. You're going to see many tables, and generally, depending on what class you have, you're generally going to be given a table. What'll happen here is you'll see the intersection of the number of periods. In this case, I have 12 different years, and the interest rate, and this is the market interest rate. I'm going to stress that a few times. This is the market interest rate we're looking for. A couple of things to be aware of here. You want to make sure you have the number of periods. If you have, let's say, a 10-year bond that has 2 periods per year, in other words, it pays interest twice a year, you would actually need to find the 20-year or the 20-period line, and you would also need to make sure that your interest rate, which is probably given to you in an annual rate, you would need to divide that by 2 to get the semi-annual rate. So keep that in mind. I'll stress it again later. For our example, we're just talking about an annual bond, and it's going to be a 10-year bond, and we're going to see the market is 10%. So our factor is 0.38554. Factor tells you is the present value of $1, a lump sum of $1. So to find the present value of $100,000, you multiply that factor, 0.38554, by the $100,000 amount, and you end up with $38,554, as we said earlier. Now, what we have here is Excel. So I created a little chart here just to illustrate a point. So I'm putting in our market rate, our stated rate, the bond maturity, in other words, the life of the bond, and the interest amount. We need this for one of the calculations later. So what we're going to see, I'm going to refer to both of these separately, but first of all, we have the present value of $1. Now, what we do here, I have the formula inside of this cell, but I've also included it to the right. If you say equals PV in Excel, it's going to give you this little chart here telling you what you need to fill out. And I referenced certain cells. T12 was the market rate. That's a key thing. When using any of these calculations or the table, you always have to use the market rate. The only thing you use the stated rate for is to calculate the cash interest payment. To calculate the price of a bond, you have to use the market rate. So we'll type in PV, and then we'll put in T12 was the market rate, comma, and you can see down here was a rate. Number of periods was 10, just 2 lines down, T14, comma, 0. It's not a payment, it's not an annuity, so our payment is 0. There is no payment in the interim. It's one full amount down the road, so we'll put in 0. T18 is our future value, and that's actually this $100,000. We're trying to find the present value of that future amount. Now the type, this is not so important. It's really when we're talking about annuities more than anything. I just put in 0 for an ordinary amount. When you type that in Excel, it'll give you a little prompt as to what that is. For the present value of $1, we're going to use 0. And what we end up doing, the $100,000 is the face amount, but then over here you'll see the result that Excel gives you. It's $38,554.33. So just as we expected. Now the annuity interest payments, here we have $8,000 in interest payments for 10 years. Now by the way, that was the $100,000 price multiplied, if we go back here, by the 8% stated rate. That's how we calculate the $8,000 interest payments for 10 years. So it's going to be a total of $80,000 in cash. Now, that'll be in the future. It's going to be worth less than that today, just like any other future value. So if we were to use a 10% market rate, today's value would only be $49,156. That $80,000 in the future would only be worth just short of $50,000 today. The annuity formula it's manipulated from the other version. You would take the R, in other words, your interest rate, divided by 1 minus 1 plus that interest rate to the negative nth power. So again, you can certainly work that out mathematically if you prefer, but the table is the best way to go. It's the nice shortcut they're usually provided for you. So there's a difference with this formula, though, with this table. You know, all of our factors before were less than 1. Here they're more than 1. I'll explain that in just a bit, but for right now, if we look at the 10 periods and the 10%, our factor is 6.144567. What that tells us, remember, this is a total of 10 payments. So our factor should be less than 10 because we're going to multiply this by one of the payments. So it should certainly be less than 10. We multiply one interest payment by that 6.144567 factor, and we get $49,157. In Excel, you can do the same thing. It's still the PV formula, but we're only going to need the first 3 items. Notice the FV, the future value, and the type have brackets around them implying that they are optional. We need the rate, still 10%. We need the number of periods, it's still 10. And we do need the payment in this case. It's going to be an annuity payment of $8,000. That's all we need. And then you'll find out that the present value is $49,150, close to $57. So the price of the bond is going to be the sum of these two present values. Our bond, our $100,000 bond, would price at $87,710.87 in this case. And that's what we're seeing here. Now there are a couple of key things to remember. The interest rate we need to use for these calculations, they are the market rate, not the stated rates. The only reason we need the stated rate is to calculate the actual cash interest payment, which we need for the annuity calculation. And then as a reminder for that annuity calculation, multiply the factor from the table by only one of those interest payments. Now, if you make a mistake there and you try to multiply it by all 10 payments, you should realize very quickly that that is just illogical. Your price is way out of line. It'll be way, way higher than it should be. So as you're looking through it, keep in mind from earlier discussions, you should know when there's a discount or premium. In this case, we're paying, the stated rate shows that this company is paying 8% when the other companies on average are paying 10%. So if this company is paying less, it should indeed be a discount. 87,000 is less than 100,000, so it's issuing at a discount. A couple other things I want to point out here. If we go back to these factors, the higher the number of periods, the lower your value is because you're waiting much, much longer to get this money, so it's going to be worth even less today. Furthermore, the higher your interest rate, the less the value is going to be today because you're missing out on all that interest. In other words, you're carving out a lot of interest. But notice, in every single case, this factor is less than 1, which means your present value, if you go across any amount of time, it has to be less than some future value. And that takes us to the end of our discussion here. Hopefully this helps you to price bonds.